Welcome to the Explainer. Today, we're going to demystify one of the most fundamental pieces of technology in our modern world, the database. And more importantly, we're going to learn the language we use to talk to it, SQL. I mean, just think about it. Every single time you stream a movie, buy something online, or scroll through your social media feed, you're interacting with a database. It's this invisible engine that's always running in the background. So let's pull back the curtain and see how this whole thing actually works. So for this explainer, we're going to follow a really simple path. First, we'll cover what a database even is, then we'll get into how to structure our data, ask it smart questions, connect all the dots, and finally, really understand the power we have to manage that digital world. Okay, so what is a database, really? Well, the easiest way to think about it is to imagine a library. But, not just any library, a super organized, high-tech digital one. Right, it's like a library where every single book, every piece of paper is perfectly cataloged. This setup allows you to find any little piece of information you need in like an instant. It's not just a random pile of data, it's a system that's built for incredible speed and precision. So how do we build this amazing digital library? I mean, you can't just throw all the books on the floor, right? You need bookshelves. And in the world of databases, we have to build a structure first. That's where tables come into play. Each one of these tables is basically a grid of rows and columns, a lot like a spreadsheet. So you might have one table that holds all your customer info and another one that holds all your product info. By keeping different kinds of data separate but organized, we keep our whole digital library perfectly neat and tidy. Now, to actually build these tables, we use a special language called SQL, which stands for Structured Query Language. It's just the set of instructions we give to the database. This command here, create table, it's kind of like telling a carpenter, hey, build me a bookshelf, call it author, and make sure it has two slots, one for the author's ID and another one for their name. And here's what you get, a really clear blueprint for our data. This table definition tells the database exactly what kind of information to expect, like an author ID and an author name. This structure is what guarantees that every single piece of data has its own proper home. Okay, a library is pretty useless if you can't find the books you're looking for. So once our tables are built and full of data, we need a way to ask for specific information. In SQL, the key to asking pretty much any question is the select command. You see, if we just ask to see the entire books table, we get everything. And honestly, that's usually way too much information. Most of the time, we're looking for a very specific, targeted answer. So let's say we don't really care about the book ID or the publisher ID right now. All we want is a simple list of books and what they cost. To get just that, we have to refine our question. And this is how we do it in SQL. We say select, and then we just list the exact columns we want, in this case, book_name and price. Then we tell the database which table to look inside using from books. It's just like walking up to the librarian and asking for only the titles and prices and nothing else. And look at that. Here is our result. The database comes back with this neat, clean table showing exactly the two columns we asked for. It's incredibly fast, super efficient, and totally precise. This is really the fundamental power of querying a database. Now, pulling data from one table is useful, for sure, but the real magic, the thing that makes databases so powerful, starts when we connect information between tables. This is the whole idea behind a relational database, building relationships in your data. So here we have data from two completely separate tables. On the left, we've got our customer orders. On the right, our book information. And notice, they're separate. The order table has no idea who the book's author is, and the book table doesn't know which customer bought it. So that leads us to a really important question. How do we figure out which customer placed an order on a certain date? To get that answer, we somehow have to link these separate tables together. And the way we do that is with a command called a join. A join is an SQL instruction that basically tells the database how to connect two tables. It looks for a common piece of information like a customer ID that exists in both the customer table and the order details table, and then it uses that connection to merge them. And there it is. After the join, we get this brand new combined view of our data. We can finally see the customer's name right there next to their order details. And this isn't just about making a pretty report. This is how businesses turn scattered bits of data into real, actionable intelligence. So far, we've focused a lot on asking questions, but SQL is so much more than that.
It's really the complete language for creating, managing, and controlling the entire database environment. You can kind of think of SQL commands as being split into different categories. First up is DDL, or Data Definition Language. These are the big, powerful commands that are like the architectural blueprints. That create table command we saw, that's DDL. So are commands to alter a table's design or drop it completely. Then the second category is DML, or Data Manipulation Language. Now, if DDL builds the bookshelves, DML is what actually puts the books on them. These are commands like insert to add a new book, update to change its price, or delete to remove it from the shelf. And finally, of course, this whole world needs rules. Just like a library has librarians, a database has a permission system. So if you want to create a new table, your user account needs to have the right privilege. This is what ensures security and maintains data integrity, which is just a fancy way of saying it keeps the data accurate and consistent. And that really gets to the heart of it, doesn't it? Learning SQL is like learning the language of data itself. It gives you the power to go beyond just looking at information and to actually start asking it questions, finding hidden connections, and uncovering the stories that are hiding inside.
So this is what I really want to leave you with. A database isn't just some static warehouse full of files. It's a dynamic, living universe that you can actually talk to. The most important skill isn't just learning the code, it's learning to be curious and to ask the right questions. So what would you ask first?